right, let's take a look at a problem with a banked turn with friction. Not without, but with friction. So this car is moving towards us with a velocity high enough in order to need friction along the plane. So let's be clear about that. The friction would in fact be in this direction here. The net force, the net of all forces, is going to be in this direction because it is moving horizontally in a circle, where that net force is going to be equal to that net force, that sum of all forces, is going to be equal to ma, which is in turn equal to mv squared over r. All right, so let's take a look at the forces. Okay, so what we've got going on is we have a force of gravity acting straight down. We have a normal force acting perpendicular to the plane. And we also have the force of friction. The force of friction is acting down the plane in that direction there. And so the sum of all forces will give us the net force. We have components. We have a component to the normal force that is vertical and horizontal. We have the same thing happening, if I can do it in a different color, for the force of friction. So there's an x and y component to the force of friction. So what we need to do is we need to break down all of these things into their x and y direction. Okay, so let's move this off to the side and do just that. So we're going to say that the sum of all forces in the y direction is going to be equal to, let's see, we've got mg acting down, so let's call that negative. So we have negative mg plus any positive forces. And in fact, let's keep with the negative forces. Do you see that the force of friction is actually acting in a negative direction? So we have a force of friction in the y direction plus the force, the normal force in the y direction. So if we have this here as being theta, then that means that this here is theta, and this here is also theta. So let's break those down. That means, and of course, by the way, this is equal to ma, and in this case, in the vertical, it is equal to 0. All right, so that means that we have that negative mg. We have, let's see, the force of friction in the y direction. That is going to be the opposite side of the triangle. So that's going to be sine theta times the force of friction plus the normal force in the y direction, and that is going to be cosine. So cosine theta times the normal force. And of course, that is all equal to 0. Okay, so what we want to do is we have two unknowns here. Okay, that is the crucial part. We have two unknowns. We have this unknown and we have this unknown. So what we want to do is we want to solve this equation for one unknown, and we're going to need two equations. So by solving this equation for the normal force, we can then take that value and substitute into our second equation and then solve for the force of friction. So that's what we're going to do. We're going to solve for the force of friction here. And let me just go ahead and do that. All right, so add mg to each side. And also sine theta times the friction force. That is going to equal cosine theta times the normal force. All right, so solving for the normal force, we get that the normal force is equal to mg plus sine theta times the friction force over cosine theta. Now what we're going to do is we're going to take this approach all over again for the x direction. So the sum of all forces in the x direction is equal to ma. Well, this is going to be mv squared over r, and that is relative to our triangle going to be equal to the x components here. So we have the force of friction in the x direction plus the normal force in the x direction. All right, so looking at our triangle, here, that's going to be cosine theta for the friction force, and here we're looking at sine theta for the normal force. So mv squared over r equals, we said that was going to be cosine theta for the friction force, so cosine theta times the friction force plus sine theta for the normal force. All right, so let me kind of just restructure this a little bit. I could solve for the force of friction here. So let's see, mv squared over r. Let's see, we're solving for the friction force. So let's subtract sine theta times the normal force. Sorry if that's a little ugly. And that will equal cosine theta times the force of friction. And divide each side by cosine theta. So what we've got here is, let's see, well, you know what, let's just leave it as is for now. All right, so let me finish by doing this. I'm going to make this fairly quick. What I'm going to say is that whatever value we get here, given these knowns, where we have a mass, we have a velocity, and we have a radius to our circle, we are going to give that angle, and by the way, we also have an angle, excuse me, on that. So let's just say that theta is equal to, I don't know, 20 degrees, whatever it may be. So whatever theta is going to give us some value here for the normal force. And then whatever value we have for the normal force, we will then take that and we're going to substitute that value into here. And of course, at the end, divide by cosine theta in order to get a friction force along the plane. And by the way, that friction is going to be along the plane. Okay, don't forget that. All right, so hopefully this helps. Let me know if you have any questions, and take care until next time.